So one of the last things we need to explore before we leave behind the scientific method is just this progression of ideas in science. And really it's just a matter of taking a look at how much data, how much evidence is there to support a particular concept or particular idea in science. So everything starts off as a hypothesis, this possible tentative explanation, this educated prediction to a question, in which case the scientist needs to then gather additional information through actual experimentation, right? So long as those experiments continually get reproduced, continually produce similar data, that hypothesis continues to get, maybe correct isn't the best word, but supported over and over and over and over again, we may move into the realm of something called a scientific theory. So hypotheses start off simply as saying something like a plant obtains their energy from the sun. And this is a possible explanation for a question. We're going to gather data, we're going to do experiments on that. But we continually find that, yes, we stick a plant in the dark and it dies. Well, then perhaps that is in fact how this process works. So given enough support, we may move into the realm of something like a scientific theory. Now be really careful with that word theory, because when we talk about something as a theory in everyday speech, a lot of times that term gets utilized kind of as, oh, it's just a theory, right? So we're using it in everyday speech oftentimes to sort of mean that it's just kind of a guess, right? But in science, when we talk about a scientific theory, there is a whole large chunk of information, experimental data, lots of evidence to support the statement that we're making. Now, one thing to understand is that unlike a hypothesis that's very specific to an experiment we're running, a scientific theory becomes a much broader statement. And it's really going to explain why a whole bunch of hypotheses that have been tested many, many times, and all of these different hypotheses continually get supported, culminate into an explanation for this large body of information. It's an overarching framework. And so theories are useful to explain and predict the outcomes of other experiments because they explain why something works. That being said, they continue to get tested, and there are times in which case they are flat out wrong. All right, something like for long periods of time, people thought the Earth was flat, and all of this data seemed to back that up. If I look at the horizon, other than mountains or things like that, it seems to be flat, right? Well, we eventually got ships to sail around the world and end up where they started without having to backtrack. Obviously, the Earth isn't flat. We didn't fall off the face of the map. We get out into space and we can see that it's a sphere. More often than not, however, it's not that we throw the entire theory out as being wrong. It's more that it gets modified. So as we continue to adjust our understanding, technology gets better and we can test more things, we get more data. It's more often that the theories get adjusted to compensate for this new information as opposed to just getting discarded completely. Some theories out there talk about cell theory, we'll talk about theory of evolution. All right, these are all theories that have been adjusted over time because new information has come about. Not that what we previously knew got completely thrown out the window, just that we added to it and modified the way we understood things as things came about. So theories, they're a big thing, and I'm going to go back just because to make this a really big deal. They're why statements. They're why things happen. They're explanations for why things work the way that they do. Alright. Scientific laws, on the other hand, are sort of on the same plane as a theory, but big difference is they now only explain what's happening. They don't give us a rationale or a reason behind why it works. They just state what will happen given a certain set of criteria, given a certain set of results. Now, I have in here that, unlike theories, scientific laws no longer get tested, generally accepted as true. Be careful with that one. While that may sort of be the case, there are scientific laws that are still continually being tested, and we may find we have to adjust these as well. Alright, so these guys' laws explain what, not why. They also summarize large amounts of experiments and lots of information. But I really am going to caution you about the whole no longer being tested thing. I threw in here the big example. Most kids know Newton's laws of gravity, right? And yet we're still testing those laws, maybe not necessarily here on Earth, but we're testing them out in space. And it is possible that we may find information that forces us to adjust those laws in other places in the universe. Okay? So be careful with this statement. In fact, I wouldn't be opposed to you just kind of crossing that part off. Because we are still testing them. And new technology and new information may force us to adjust the way that these work. Alright? A lot of these laws are mathematical. Alright? All of Newton's laws have math that supports them, math that helps to explain them. They don't really explain why they work, just a set of parameters that if I have mass and acceleration, then I can figure out velocity, things like that. That being said, there are other laws out there, something called the law of superposition, so where your fossils are in the geologic record, the deeper you go, the older they are because they get put down first and new layers of dirt get piled on top of that, and so newer fossils should be closer to the surface. That's just another example that's actually not math-based. But they're all laws. They're explaining what, but not necessarily what. So if we look at these in terms of one being more likely to be wrong or unsupported, your hypotheses are going to come first. They're going to be the least supported with the least amount of evidence because they're so specific to a single experiment that may or may not have been even run yet. Your theories and laws are in this progression of theory perhaps being a little less supported than a law, although, once again, I would even beg to say we could draw a double arrow here and say these guys are kind of on the same plane because this is explaining why something works, this is explaining what is happening, but not necessarily the why behind it. Something else to consider when we're talking about science is that there are limitations in the questions and the experiments that we can actually run. So science is in and of itself a way of knowing something, but it's not the only way. When we talk about science, it's limited to being able to address natural explanations for natural phenomena. So I can't use science truly to address things like personal preference. There's no way to know for sure that somebody's favorite color is purple, other than to ask them. And that is open to subjective interpretation of their response. Science attempts to be objective, alright, to gather clear-cut data. You could lie to me, or that information could change over time, okay? So not necessarily something that true scientific methods, true scientific experimentation is going to be able to actually address. Although we utilize pieces of it as a way to gather and interpret data all the time. So just be careful with that. I also can't use science to address supernatural phenomena. All right, do ghosts exist? I can't apply science to religion. All right, those aren't things that science is able to actually interpret. So there are limitations to what science can do. All right, and so just keep that in the back of your head. We're able to address natural explanations for phenomena that we can see, we can experiment on. But that doesn't mean everything in our world is going to be capable of having a scientific explanation or a way to test. And then ultimately, the hope is that we can actually use that information for some sort of purpose. So science in and of itself is just our understanding through observation and experimentation, this whole process of the scientific method. But the conclusions and the data and our understanding that we gain from doing science often ends up being applied. And that's really where the technology comes in. So by definition, technology is the application of science for some sort of purpose. So computers, for example, understanding how circuits work. Microprocessors, engineering even is part of that technology or application piece of science, now allows us to utilize this computer to process data, to communicate information. Medical applications, we do this all the time, right? So our understanding of how the human body works, metabolism works, the way that your body processes medications, all of that can obviously be medical, or even using the machine that you've got up here to do surgery, so we don't have to make these giant incisions in your body every time we need to do something. Now we can make all these little ones and use that technology to make you better. Genetic engineering, understanding how DNA and genes and proteins work, are being utilized to adjust the products that we make, foods, livestock, so that we can make them more hardy or bigger or better for whatever particular application we need from there. So ultimately, technology is using our scientific understanding for some sort of actual process in the end.